Hi everyone. Last class we were discussing about integration. Today let's see the continuation. Evaluate the definite integral 0 to 5 by 4 sin x into cos x by cos power 4x plus sin power 4x dx. We need to integrate this one. Let assume I equal to integral 0 to 5 by 4 sin x into cos x by cos power 4x plus sin power 4x dx. Then given function we can reduce the numerator and the denominator divided by cos power 4x. Then we get integral 0 to 5 by 4 sin x into cos x by cos power 4x by cos power 4x plus sin power 4x divided by cos power 4x into dx. Then we get integral 0 to 5 by 4 sin x by cos x. We can write tan x. Then cos x will be cancelled. Then we have 1 by cos squared x. That 1 by cos squared x we can write secant squared x. We reduce the numerator and we can reduce the denominator also. Then cos power 4x by cos power 4x we can write 1 plus sin power 4x by cos power 4x. Sin x by cos x equal to tan x, we know that. Therefore, here also we can write tan power 4x into dx. Now, we can go for substitution method, then we can integrate. Then tan squared x we can assume as t. Then differentiating this function we get tan squared x. Differentiation of tan squared x is 2 tan x into secant squared x equal to differentiation of t we can write dt by dx. Then reduce this one, 2 we can transpose the next side, dx we can transpose this side. Then we get tan x into secant squared x dx equal to dt by 2. Then we can change the limit also. When t equal to 0, then t equal to tan squared 0. We know that tan 0 is 0, therefore t equal to 0. When x equal to 5 by 4, then tan squared 5 by 4 equal to t. Then tan squared 5 by 4 we can get t equal to 1. Then we can change and write limits x equal to 0, then t equal to 0. When x equal to 5 by 4, then t equal to 1. Therefore, I equal to integral 0 to 1 by 1 plus tan power 4x, you can write t squared into tan x into secant squared x dx, we can write dt by 2. Then we can reduce this one. 1 by 2 is the constant, we can take out 1 by 2 into integral 0 to 1 by 1 plus t squared into dt. Then 1 by 2 into integration of 1 by 1 plus t squared dt, we know that tan inverse of t, and 0 to 1 is limit value. Then we can applying the limit values. 1 by 2 into tan inverse of 1 minus, then we can replace the lower limit, tan inverse of 0. Then we can reduce 1 by 2 into tan inverse of 1, we know 5 by 4 minus tan inverse of 0 is 0, that will replace. Then we get 1 by 2 into 5 by 4. Then multiplying the both the values, then we get 5 by 8. Therefore, I equal to 5 by 8. This is the answer. The next one, evaluate the definite integral 5 by 6 to 5 by 3 sin x plus cos x by square root of sin 2x into dx. We need to integrate. Let assume I equal to integral 5 by 6 to 5 by 3 sin x plus cos x by square root of sin 2x into dx. Then next we get integral 5 by 6 to 5 by 3 sin x plus cos x by square root of the sin 2x. Before we can add plus 1 and minus 1. Then 1 minus 1 plus sin 2x into dx. The next step, integral 5 by 6 to 5 by 3 sin x plus cos x by square root of 1 mi- from these two terms I am going to take as a minus is the common factor, then minus of 1 minus sin 2x into dx we get. The next step, integral 5 by 6 to 5 by 3 sin x plus cos x y square root of 1 minus of 1 we can replace sin squared x plus cos squared x equal to 1. That will replace sin squared x plus cos squared x minus sin 2x. We know that 2 sin x cos x, that also will replace 2 sin x cos x into dx. The next step, integral 5 by 6 to 5 by 3 sin x plus cos x by square root of 1 minus of sin squared x plus cos squared x minus 2 sin x cos x. We can use the a minus b whole square formula. We can reduce, we get minus of sin x minus cos x whole square into dx. Then reducing this integration, we can go for substitution method. Then we can assume t equal to sin x minus cos x equal to t. Then differentiating this function, we get differentiation of sin x is cos x minus differentiation of cos x is minus sin x equal to differentiation of t is dt by dx. Then reducing this one, cos x plus sin x into dx equal to dt. Then we can change the limit value when x equal to 5 by 6 t equal to sin 5 by 6 minus cos 5 by 6. We can replace that values t equal to 1 by 2 minus root 3 by 2 equal to, we can reduce 1 minus root 3 by 2. When x equal to 5 by 3, then t equal to sin 5 by 3 minus cos 5 by 3 equal to t. Then replacing the sin 5 by 3 and cos 5 by 3 value, we get root 3 by 2 minus 1 by 2. We can reduce root 3 minus 1 by 2. Then when x equal to 5 by 6, then t equal to 1 minus root 3 by 2. When x equal to 5 by 3, then t equal to root 3 minus 1 by 2. Then therefore I equal to integral 1 minus root 3 by 2 to root 3 minus 1 by 2, 1 by square root of 1 minus sin x minus cos x, we can t value, then 1 minus t squared into sin x plus cos x into dx. We know that dt, that dt will replace here. Then we get integral of root 1 minus root 3 by 2. We can take minus is the common factor, minus of root 3 minus 1 by 2 into root 3 minus 1 by 2, 1 by square root of 1 minus t squared into dt. As we know that 1 by square root of 1 minus of t squared equal to 1 by square root of 1 minus t squared. Then it is an even function. Even though t is a minus, then we can square it, we can get the positive value. Therefore 1 by square root of 1 minus t squared is an even function. Then if f of x is an even function, we know the property integral minus a to a f of x dx equal to 2 times square integral of 0 to a f of x dx. That we will use the property. Then I equal to 2 times integral 0 to root 3 minus 1 by 2 into 1 by square root of 1 minus t squared into dt. Then we get 2 into integration of 1 by square root of 1 minus t squared into dt. You know that sin inverse of t 0 to root 3 minus 1 by 2. When applying upper limit and lower limit, we get 2 into, while applying the upper limit, sin inverse of root 3 minus 1 by 2 minus will 0 will replace here, sin 0 is 0. Then therefore I equal to 2 into sin inverse of root 3 minus 1 by 2 is the answer. Next one, prove that integral minus 1 to 1 x to the power of 17 into cos power 4x dx equal to 0. We need to integrate this function, we get 0. Let assume I equal to integral minus 1 to 1 x to the power of 17 into cos power 4x dx. Then we can take and write the given function f of x equal to x to the power of 17 into cos power 4x in cos power x 4x. The given function is even or odd. We are going to verify. Suppose x, we can replace minus x in that function. Then we get f of minus x equal to minus x equal to the power of 17 into cos power 4 minus x. X to the power of minus x to the power of 17 is, we know that, minus x to the power of 17 into cos power 4 minus x, we know, cos power 4x. Then we get minus of x to the power of 17 into cos power 4x. Then x to the power of 17 into cos power 4x, we know that f of x. Then we can replace minus of f of x. Hence f of x is an add function. If f of x is an add function, then we know the property integral minus a to a f of x dx equal to 0. Here we can apply the property. Therefore I equal to integral minus 1 to 1 x to the power of 17 into cos power 4 into cos power 4x dx. Then we can applying that property, we get 0. Hence it is proved.